Hello everyone and welcome back. Now we are going to another very important, module of our ETAP course, which is the arc flash analysis. But before diving into how we can perform the arc flash analysis in the ETAP, we are first now going to have a slide here which will also be attached. So I have preferred to have one single page slides versus numerous slides that you can make you can be confused, or it's better to have the information concentrated. But also you are free to search different literatures how to and to see how it's arc flash analyzed and what it is arc flash. But we are going to have now a simple and very clear explanation. So whenever we see workers that work in high voltage environments, the workers that do welding, or the workers that in construction or electrical manufacturing, we have seen that symbol which is the arc flash, and which is here in ETAP. It's represented by this triangle here, which means the hazard one, and which means the danger because of the high voltage. But what is simply an arc flash? It's a phenomenon where a flashover of electrical current leaves its intended path and travels between the conductors and to the ground then. And the result is that when a human is approaching this kind of fault here, it can be, let's say, it can happen a big explosion or a big energization here of the conductors, and it can damage the person, which can lead to from minor, let's say, serious injury, and also death can occur. So there are some levels here from the moment of explosion. So what can be an arc flash in an everyday, let's say, everyday case? So imagine that in a transformer cabin there is an increase of the current of one of the faces, and also this face is very near to the cabin, to the metallic cabin, and when the person go to open it, it is energized, and it can cause let's say arc flash, which is a huge energization wave that can kill the human. So there are some areas here that are being approached and be described, which is the restricted approach boundary. So you should not be approaching beyond this level here, as you can see here on the bullseye explanation. And there is the prohibition, limiting, and there is the boundary. But how do we know, for example, every one of you can ask, how do we know which is a distance? Of course, if we have, let's say, all the requirements of the voltage levels, of the power, the current, and the circuit breakers, we can also always, let's say, do an analysis. So in order to be protected from energized equipment here, let's jump to ETAP and to do an analysis, because this is very important for at least all the industries that need to perform an arc flash to protect its employees. And one thing that I wanted to mention before we jump to the ETAP is that to prevent this, because sometimes the calculations cannot be like 100% accurate, but always to be as much safe as we can, is that we need to use some that are called PPE. That I'm going to write it here now. And to be protected, you need to use protection that is needed is PPE, which stands for protection, personal protection equipment. Those equipments can be, for example, gloves, can be shoes, can be here the mask, it can be face protection, hands protection, full body protection, and any other protection that is being determined by the standardization. So now, in order for us to jump into the analysis, we will need to do some changes. So first we need to go to the edit mode. Why we'll need to do some changes? We cannot perform the analysis here into this kind of high voltage transformers, or we cannot perform it here, because imagine that if something will happen in a 10 megawatts, let's say, generator, if a fault can happen, of course the arc flash will be extreme too much, and it can automatically, it will be shut down the generator. It can cause a lot of explosions. So we can use it here, but we are going just to extend a little bit, let's say, the schematic diagram. So we are going now to have another step transformer and a busbar, which will be let's say bus 3, and we will go for the, let's give it a name. So it will be personnel equipment. So here we are going to put at least 0.24, which is around 240 volts, which is a normal voltage when the employees can operate. Or in order not to confuse that, we can go for the equipments, and then we will need for that here, we will need to insert the transformer, and we need to set the rating here at 0.24. And the rating will be, primary will be 33 and secondary will be 0.24. Let's connect it here. So as you see, we have connected it correctly. And the rating will be, let's say that the workers will work not, of course, on megawatts, because it's extremely too much, but it will work on kilovolts, or in megawatt it will be like 0.4, or it can be 40 kilowatts. So let's say that we have some welding or cutting machines here that we are going to use, and then this is the equipments before going to the load that they are going to use. So welders, hand cutters, and we need here to insert a low voltage circuit breaker. We need to connect that, and here, to make it more simple, we'll set the worker, and let's insert it here, and let's remove that. Make sure that you hold the space button on the mouse here, and let's click all of this, and we can move it a little bit down so we can have some space here. And this will be also the load. So it will be worker load, and which will be at least, and the rating will be not in, it will be at least 20 kilowatts, and this is how much it is. At least will be like to use only like almost active power ones. And here is, let's say, mostly what we have done here, that we have created an area here. So here is where we work. So we are in an industry here factor, and we are working with some equipments of 240 volts. So now we need also, we have to circuit breaker in case that something happens for the employees. So we need to double click it, and we will say the protection CB. We'll go to ratings. Now we are not going to touch here because we are going to select a model here, and as we see for the low voltage we have a lot of options, but mostly what interests us more is the type of library that we are using. So let's click here into the library, and you can select whatever circuit breaker that you want here, but in our case we are going, for example, for an ABB, or let's say you have a lot ETAP concludes a huge range of libraries here, and you can go for Allen Bradley or General Electric or much more. So for example, for the ABB, we need to choose something that is related to our voltage. So we need to choose something that is 0.4, and here is how you can select your own circuit breaker based on the size, based on the fuse and the kilovolts and everything. So you see here how much it is, how much is the standing currents, and here we need to choose a model, but we need to choose a model based on our voltage level. Here, as we see, we don't have 0.4, so we can go for at least 0.3, 0.243, or we can go for Allen Bradley here. Let's see if Allen Bradley has something, or we can go for the, okay, we can go for this. And the size of the amperage we are going to make, for example, let's do a simple calculation. So we are having at least 20 kilowatts by or 2000 watts by 240 volts. So we would like to go for at least 80 here. So what we do, we have done just a calculation of an ohm law, and we click OK. So you see automatically this table is updated with the ratings and with the size. So after this kind of amperage, it will be automatically switched. So let's click OK now, and this is how we have modified a little bit our diagram in order for us to perform the arc flash. Now, after we have done this model, and remember this is done only for the sake of simplicity, we go to the arc flash here, and as we already know, the first thing to do is that we go to the study case and to see what is offering. Here we have what is the study case, so we'll go for the arc flash 1. Everything that needs to be here needs to be left as a default, as it's, let's say, is the most model that is near the short circuit analysis. So you see that what can we fault here, so we are going to fault the worker one, and let's go to the fault. The type of method we'll go for the one of the IEC. This is the arc current variation. Clearing time, just leave it as a default. And for the parameters and adjustments, we are going to have another lecture, so don't worry for that. We're going to make it very detailed. And here you need to say that update the fault current to the bus, because we'll need to see some result. And we click OK. So here we see that it's already selected in the red. And let's see what we have here. We have two methods. We have the arc flash here and the fault insertion. So we'll go now for the run arc flash calculation, which will give some results. And here, if we run the arc flash here, it's made, this is only done based on the standard here. So it will create some faults here, and it will calculate how much is the distance or how much is the energy in coulombs. And here you have the fault insertion, which is a sequence of faults, and is another type of analysis. And now let's go for the run arc flash now. Let's save it at the arc flash study case 1 and see what is going to happen. Make sure that you have selected your bus, and to see that we have some errors here. So to see that for the transformers, we need to go back and to modify. Okay. So here it is 0.24, while the load is 0.24. It's okay. And let's go and create some impedance here. Okay. And let's see again what if we have minimized a little bit of errors. So we see that the equipment is out of 40% for the bus nominal. Okay. So 0.24, 0.24 equipment rating. So the secondary is 33, while here we need to put 0.24, and the primary is 33, which is at least 0.04. Let's click OK, and to see. It says warning, the PPA approval required. So this is how you improve the power protection equipment here, the personnel. And it asks, like, it make it more visible and make more real. It says that in order to calculate that, you need also to include the equipments. So you click OK, and you see that here we have some we'll have some results here. We'll need just to wait, and here we have successfully done the arc flash analysis. Just we need to select here, this is the short circuit current, how much is coming, and here it says that we have the level A. Also in the next lecture we are going to explain a little bit more about those, but first we need to see what type of level is. So in the display options here, you can see how much is, for example, you can go to the for example, to see the AC, or to see the ACCD or colors, and to see how much is the, if you want to see any more variables here, for example, so see the kilovolt one, rating, and for the results you want to show the units, for example, and for the arc flash you need to see also the location, types of loads, and you see that you have now a lot more, let's say. So let's see what is here. So this is the area, which is around 0.2 meter, and remember what we talked. And this is how much is the coulomb for calories. This is the heat, which is the calorie per centimeter square. So this is how much is going to be released if we have a short circuit fault here. And remember that you need to stay a little bit, let's say 45.7 centimeters. So this is the restricted space. And this is how much it will cost. If it is an arc flash, you need to stay this, the worker needs to stay at least 45.7 centimeters. So I hope you have enjoyed this lecture, and see you to the next one, which will continue a little bit for the arc flash short circuit. Thanks a lot, and thank you for